Now, supervised. So, supervised means supervised actually and the unsupervised are in context of the data, not in context of the algorithm first. So, what is supervised data? The data which has labels or answers, and this is just opposite of that, the data which doesn't have labels or answer. Now what does it mean by labels or answer? Let us suppose we have this data. Now let me show you that how exactly it works. So we'll use ChatGPT. Now I'm saying create a supervised data for predicting house price with some realistic input features. Let's see and what it will understand. Are you able to see that what exactly it is doing? So I said only that create a supervised data for predicting. So this is a little bit wrong. House price with some realistic input feature. So see, size square feet, number of bedrooms, number of bathrooms, distance to city centers in miles, age of the house in years, and this is the house price. So this house price is the label on basis of the given information. Like this is the 200 square for one house. This is what is the square feet of that house? 2000. How many bedrooms? Three. How many bathrooms? Two. How much the distance? How miles it is away from the city center? So 5 miles. Age of the how older that house is? 10 years older. And what is the price? So that is the label which we have to predict. So here we had the label. Okay, so this is the label means you have the answers for the every input. Now is there any confusion in understanding that what is supervised? Guys, please be vocal. So whatever it is, just answer it. Okay, okay. Now, so we understand the supervised. Now the supervised divided into now two parts. Okay, so understand here now. Supervised divided into two part. The first is regression and the second is classification. This is regression and that is classification. Two things. So now let's understand what is regression and what is classification. So I said the labels. Supervised data which has the label which has the answer means this both has the label, the regression and the classification. But if your label, if the label of data is continuous, if the label of data is continuous, then we will use the regression algorithm. Now what does it mean by continuous? So let us suppose speed is a continuous data because speed value could be from 0 to any infinite value. It could be 0 0.2, 9.10, 60.3, any values. Like height could be any value. Like I can say sales, price, profit, loss. These all are the continuous data. So you understood now meaning of the continuous data, numerical value completely. So if your label, if your y which you have to predict, if that is the continuous or the numerical, it means that's a regression problem. Now, if the label of data is discrete, discrete or categorical, then then that's a way there we will use the classification algorithm. Now what does it mean by categorical? Let's suppose if I want to predict that whether a student will pass or fail, this is one. Whether there will be tomorrow rain or not, rain or not rain, like this kinds of, whether the image is dog image or cat image. Understand? These all are the classification. Something this is if you are for fruit apple or orange. So these all are the classification. Now classification can be subdivided into two parts. One is called binary and second is called multi-class. There is an one more which is called multi-label, so I'm not going on that, that is advanced, which we will understand it later. Binary means in your y, if you have only two class, like whether you have to predict which is pass or fail, that means binary. Binary means two, bi means two. Multi-class when you have a more than two things you have to predict, like whether that on the given college data or the school data, whether the grade of the student will be A, B or C. This is also categorical. Okay, so this is how it is segregated. Now, is there any confusion in supervised, unsupervised? What is regression? What is classification? Any confusion? Now let's ask a model to generate a data for classification. Generate a realistic data for a classification problem on college marks, whether students will pass or fail. Let's see what it is actually generating. See that it has generated exam 1 score, exam 2 score, homework average, attendance percentage, mid exam score, final exam score, and here it is pass fail, pass fail. So this is your target column. Target column means which you have to predict pass or fail, and this column it has the two category. So you understand, by seeing at the data and your use case, you need to understand which kind of problem it is, whether it is supervised or unsupervised. If it is supervised, do I have to apply the regression algorithms or the classification algorithms? Understood? Now, now let's understand here. In regression, there are multiple algorithms. So I'm writing here ML algorithms for regression, and here let's suppose I'm just doing this ML algorithm for classification. Now first let's see the regression. So the basic or the first algorithm for regression is linear regression algorithm. Linear regression. This is the first. Okay. Now then after, if you'll go, there are lot many in regression, like there. Let's first see here classification. So in the classification, the first algorithm is decision tree. I will come on one by one with the next classes that how these algorithms work. Decision tree, then random forest. Okay, and then SVM, then naive bias. Okay, so Apart from that, there are lot many. I'm just giving you some example. We will see it. And in regression, we can use even decision tree also, but we have to change it little bit. Decision tree regressor, its name as. Even we can use the random forest, even we can use the svm. Okay, we can use that. So that we will see that how we can do, but you need to understand it, the main agenda of that, when we have to go with the regression, when we have to go with the classification. Okay, these all algorithm we will yeah. No, it's classification. Logistic regression is the classification model. Name is regression because at the back end it uses regression technique, but at the end you will get a classification result. Though I said it, if you want, you can tweak it for the regression as well. So we will see the scenarios that how we can do, but majorly it is used for the classification. Okay, so the one part which I had left it here, if you guys have noticed, this unsupervised. Now, what is unsupervised means the data which doesn't has any label. Okay, now what does it mean? Let us suppose here we had all the information for a student data, or for the, like, whether a student will pass or fail, or for the house data on the given input. Now let me tell you about an unsupervised problem, and this is one of the best use cases in machine learning algorithms or in the AI industry. These algorithms are. Let us suppose, have you ever noticed that whenever you are using a Netflix, whenever you are using the Netflix, and when you watch any movie, there are multiple genres of the movie, right? There are multiple genres of the movie, like sci-fi, then thriller, then maybe drama, okay, then maybe romantic. When you started watching the sci-fi, it will started recommending you the multiple sci-fi. How those algorithm works? So the name of those algorithm are association network, associations. Have you ever noticed, there are a lot many clothing industry applications are there. Let us suppose you have any t-shirt, okay, any cloth you have, okay. So what you want, that and that got old. Now what you want a similar cloth or the similar t-shirt with some different design, little bit of the changes. So you will go and upload at their website your image of cloth, and it will start giving you the similar cloth with some whatever their availability according, or whatever the clothes available in their database, the similar with your cloth. It will start it. So this solved the major issues in that of AI industry. So to segregate the similar images, like that, okay. So this is how the unsupervised work. In unsupervised we do not have any uh, labels or the answers. Let us suppose, uh, first time Audi wants to open their service center or the showroom in Bangalore or in any area. Then how they would find it out the proper location, so that they will perform, like how to target that on which people you have to sell the credit card. So that's a, they perform because they do not have an answer. They don't know that who these people will take, or they do not have any. So they have their previous data without answer. On that they use some algorithm, which I will cover that how those algorithms actually works, and then you can able to understand that yes, actually by using these algorithms we can solve that problem. Okay, so I think unsupervised, supervised, regression, classification, these parts are clear. Priya, you understood, right? Okay. Now, let's understand here the basics of the linear regression. That how linear regression work. How linear regression works. So suppose we have this data in which the target column which we want to predict is the price. Okay, some values are there like 100k, 400k, 50k, 345k, something 800k. Okay, this is the price on the given like area, bathroom, bedroom, parking. It could be any number of x values like area, bathroom, bedroom, parking, facility, floors, stories, like those things, interiors, furnished, semi-furnished, all those things. Now we need to understand that on what mathematics actually linear regression works. So the formula for the linear regression is y equal to mx plus c, and this is the equation of straight line. Now, do anyone understood what is the meaning of the linear? So if I'm saying x and y here and x and y, so if I'm increasing x, y is also increasing. If I'm increasing x, y is decreasing. So in this, which one is linear? Which one is the linear relation? Yes. This both has the linear. So this line linear regression could be like that, or it could be like this also. So this both has the linear. But if something, you will get a line like this. Now this is not a linear relation between x and y. Means sometimes it is decreasing, increasing, decreasing. So this is not a linear. So linear means always understand either it is increasing or decreasing. That is the only. So these both are linear, but this is not. So whenever you have to apply the linear regression, in regression there could be the multiple algorithm. But let's suppose you try, you want to start with the linear regression. So you must check that with these all x and this y target, whether this x and y has the linear relation or not. If the x and y has the linear relation, then only you can apply the linear regression algorithm on this data set. Otherwise, you cannot. In spite of having the continuous column as a target, you cannot apply. Means you can apply, it will not throw error, but the performance will not come good. Okay, because this line or this algorithm has made in such a manner that it will always try to fit in a straight line. So if data will be like this, like this, like this, the error will be always high at some point. If line will go here, if line will go here, so error will become here high. So that will be always a higher error. Model will not perform well. So the first assumptions, assumptions of linear. This is the most frequently asked question in the interview. The first is linear relation with x and y, or you can say dependent or the independent variable. Now the second, what is the second assumption? Second assumption said that there should not be the multicollinearity. Now let me write it here. No multicollinearity. No multicollinearity means, let me give you an example. Let's suppose this is one student, and this student wants to learn Python, and This student went to the multiple coaching centers to learn Python, like coaching 1, 2, 3, 4. And he decided, their parent decided, now you will go in the two coaching centers, like in this coaching or in this coaching center for the Python. Tell me, is it a good decision that this student is going to learn the Python from the two different institute? There is no, because there is an multicollinearity between these two in coaching institute, because they explain the same concept, so that's not a good decision to go for the same. So what this multicollinearity means, let us suppose, if area if area of a house is getting increased by 5% and it is increasing the price also by 10% or like that, and if bathroom number of bathrooms are increasing by 5% and it is also increasing the price by, let's suppose, 8%, and here it is, let's suppose, increasing 10%. Now we will see, is there any relation between this area and the bathroom? Because it happens, no, if the area would be higher, automatically bathrooms are become more there, right? So if there is an always if there is a relation between area and bathroom, if suppose this area and bathroom are 80% related or the same for the price, then why would we keep this bathroom? We can remove this. So this is the second. There should not be the multicollinearity in the independent features. Independent feature means X features, whatever these features are. There should not be multicollinearity. We need to deal with the multicollinearity. Guys, you understood the meaning of multicollinearity, what I'm trying to say? Okay. Now, the third and the fourth. This one I will cover once we'll do the hands-on. So there is something called heteroscedasticity. Heteroscedasticity, that will cover. And the fourth is residual normality. So there are, if you will see where in the blocks, it will give you 4, 5, 6, 6, 7 assumptions, but these are the main assumptions of the linear regression. Okay. So now let's understand and that how now linear regression will work. Let us suppose your data is fulfilling these assumptions. Okay. So now how linear regression works. So when you have the data, let me build it quickly. So I'm just taking only one feature. This is area and this is price. I'm taking one feature. Something 500, 200, 300, 600. And here let's suppose 300 square feet, 100 square feet. Uh, let's suppose this is 200 square feet, 360 square feet area, and these are the price. Now we need to build a model like on this line by using. So I am saying, let me put this is X here, which is the area. Please focus, guys. Okay, don't get bored. Otherwise, you will not. And focus it and ask me if anything, if any questions you have. Let's suppose this is here 100, 200, 300, 400, 500, and here it is 600. And price, and let us suppose this is also starting with 100, 200, 300, 400, 500, and here it is 600. So now when area is 500, so when area is 500, what area here? 300. When area is 300, what is the price? 500. So here it is. This is the first point. When area is 100, price is 200. Okay, this is the point. When area is 200, price is 300. Okay. When area is 360, 300, let's suppose here it is somewhere 60, it is 600. Okay, so here it is somewhere. Now we have to join this point. So it is somewhere here. So now let's understand that I'm now, let's suppose I'm taking a any imaginary line here randomly. I have taken it randomly. So what would be the equation of this line? mx plus c. Now here you need to understand what is the x. X is this value. So if I am writing y equal to mx plus c, so y is what? Your price. So let's write it for the first record. So 500 equal to, I don't know m, so and the x I know 300, m into 300 plus c. This is how the first equation look, and the same you can replicate for the second record, third record, and the fourth record, right? Now here the question is, I want the value for m and the value for the c. So m is what? Your slope, and c is what? Intercept. C is what? Intercept. So these are the two things we need to know. Okay, that how to find the m value and how to find the slope and the intercept. So in this line, if you understand, this value is called c, intercept, and the angle at which this line is, this is actually called slope. Slope is, this is here, let me write dy, here let me write dx. So the formula for slope is change in y with respect to change in x. Means if I will change the 1 unit of x, how much y got changed. Okay, so if I'll change it, so from this point, like from 200, if I moved to 350, 200 to 350 here, then how much the value of y got changed? That is the slope. Now tell me, for which line the slope will be higher? For this line or for this line? For which line the slope will be higher? This is the line 1, this is line 2. Guys, definitely slope for this line 2 will be higher, because see, if you'll just assume any of the point here and we are moving here to here, see how much it has changed, is only this much. But let us suppose the same point from here, we are moving here. Now see how much y got changed, this much. So the slope, this angle will be always higher for this line. So what you are understanding means, if the x value is changing a little bit, the y is changing much in this scenario. But for this line 1, if I'm changing the x, y is not changing with that extent as compared to the line 2. So if I have to uh, put in the formula for the line 1, the formula would somehow, let's suppose, look like this: y equal to 3x. And for the line 2, the formula will look like this. Let's suppose y equal to 10x. So here, if I will put x is equal to 1, then what will be the y? 3 into 1, y is 3. But here the same value, if I put in this equation, x equal to 1, y value, what it will become? 10. Means for the one value of x, this is increasing by 10 times. But for one value of x, this is only increasing by 3 times. So this is the slope. Now what will be the optimal slope that we need? And what will be the this intercept, the optimal? So this one you got it, everyone, right? Now to get the optimal value of slope and the intercept, we have the algorithm which is called gradient descent. Okay. Now how gradient descent works? So this is the basic formula. I will not go into deep mathematics in that. Just understand here. The new point is equals to old point minus eta into derivative of old point with respect of derivative of error. So this one I'll try to show it with some good example tomorrow, so that otherwise with the math it will become too tough for you guys to understand at the first class. But gradient descent works in this manner. We will see it in the hands-on as well. So you just understand, for some any specific data points, let's suppose these are the data points. It could be the multiple lines. Okay, it could be the multiples line, like this line could be, this could be the line, this could be the line, this could be the line. So now we need to find out which is the best line. We have to find it out which is the best line. So how would we find it out that? Okay, so for that the gradient descent works. So the line, so let's suppose this is your data points are there. So some data point is here, some is here, some is here. Let's suppose this is one line, this is another line, and this is another line. There are three lines. So which line is the best fit line we need to choose? So the line which has the minimum error. So if you finalize the line, it means what? You finalize the value of slope, intercept and the slope. That's it. If the line has finalized, if you finalize this line, so definitely it has some intercept value and some slope value. That's it. And how to calculate the error? By this. I'll show you the picturization again tomorrow to how to show. So this is how. And the data pipeline, that how it works. So now let us suppose you are working a regression problem and this is your data. Okay, this is your data. So the first step is, the first thing which we will do, the work is to read the data. No, before what is the pipeline? So you have to understand the problem statement. Understand the problem statement. Like what problem statement actually it is. Okay, after that you have to understand the data. You have to understand about each features and the each uh, either by using internet or from the domain expert. You have to understand like the domain knowledge of that. Like if you are working in a retail industry, you need to grasp the, so if you are working in a finance industry, so what the terminologies they can use in that. So the domain knowledge is important. You need to understand the data completely. That's the second and most crucial important. And then third, you need to analyze the data. Analyze the data using statistics. Now, how we can analyze using statistics? I'll show you. I'll show you. Okay. And then after, you have to perform data cleaning. Now, what does it mean by data cleaning? If suppose some unwanted columns or features are there, or rows are there, some null values are there, so you have to treat those null values or the unwanted column. That is called data cleaning. Okay. Then after, something called feature selection. What does it mean by feature selection? Let's suppose your data has 40,000 records and 30 columns. But it doesn't mean no, this all 30 columns are important. If you now already gain the domain knowledge that this feature is not important and doesn't require, or either by your domain knowledge or by the statistical analysis, you have to remove the features. Or feature selection doesn't mean only the removing the feature or keeping the feature. You can generate the new feature also. Let us suppose you have the this data has this two feature x1 and x2. So what you decided that I will multiply this both feature and then I will create a new feature which is called x3. And then you think that after multiplying these two, I am getting the more better intuitions or the information for the predicting the house price or predicting whatever the value is. Understand? Then once you have done that, then you have to perform splitting the data. Splitting the data in a train test. So whenever, why we need a data split? But because I already told you in the one of the class that if suppose this is your data, so one part of the data is for the model training, which is maybe 70% or the 80%, and other part is the 30% or the 20%. So this is called the train data and this is called test data. So on the train data, you will train your model. But to evaluate the model, evaluate means to check the performance of this model, you will not use the train data. I will use the test data, completely new data. And if my model performed well on the test data, if performed well, then I will say it's a good model. And if it is not performed well, if it is not well, then again we have to go with the training. Not well, then again I have to go with the training. I have to train in the some different manner, do the feature engineering, feature selections, creating a feature proper way in data cleaning. Okay, those things we will see. This is one of the skill. And then after, there is something called scaling of data, or majorly I can say continuous data. Now what does it mean by scaling? Scaling means, let's suppose you have this data and some columns are there. So in that one column, let's suppose the values are started from 200 to something 2 crores, like that. So there are a huge difference between these two. So what scaling does actually, scaling makes the entire data in between of 0 to 1, and the values will be the same. Because see, there are the difference between 200 and 2 crores, so it can be the difference between no 0.012 the 1. It can be the I'll make this 0.000001 to 1. Still the difference is the same. Okay, but I will scale it in between, because for the model it is this is the models works well when the data are scaled in a one units. Okay, so this is how. So this is now the eighth step. The eighth step is encoding the data. Encoding of data. So this is for the categorical data. Now, what does it mean by, let us suppose you have a column here about the, here it has written yes, no, yes, no. This one you cannot feed to your machine learning model because machines do not understand the text. So encoding means what I will do, I will convert this yes to 1, no to 0, and then I will feed. So that is called encoding. Okay, no confusion. Then after here the parts came model training, or you can say first model selection, means which model I have to use for my use case. And then once you finalize your model, then model training. Now you need to train the machine learning model. And once you have trained, then model serialization. Serialization means model saving and the loading. Okay, to save the model or to load the model, which we had saw. And the last is here model evaluation. It's performance evaluation. There is something called model hyperparameter tuning also in while the training, which I will include it, we'll see model evaluation. And the last is here again, you'll have to do model deployment. Deployment, either you are using Flask, I mean with the Flask, there is a lot many. Flask is there, Fast API is there, Django is there. There are a lot many things. Streamlit is there. Once it deployed, how you can Dockerize it, how the Kubernetes, those all things you can use. And then after once it, then how would you deploy it on the cloud? So these are the entire machine learning life cycle. Okay, we need to understand. Now tell me, is there any confusion in whatever we covered? Is it clear to everyone? If you guys have any questions, you can ask because yeah, tell me. Someone was saying something. Okay. So whatever we saw it here, no, we will cover it tomorrow with the same steps. Each and every steps we will follow, and then it would be more clear to you guys to understand these every steps. Okay, the pros and the cons. And I want you guys tomorrow. I will solve a fresh data in front of you, and then I will give you a fresh data to you guys to solve that by your own. You can take the help from the chat gpt or whatever it is, but take the help as minimum as possible. I mean, take the help for the coding. Let's suppose you understood that now I have to perform the here splitting of data, I don't know. So in a gpt, ask the code, write a code for the data split in train and test for the machine learning. So to write the code and you can use, but you have to build your thinking that after that what I have to do. Okay, like this. So once your thinking has built, writing a code is not a tough part. It is easily available everywhere. Okay. Okay. So if you guys do not have any questions, I can wrap this. And tomorrow on 9:30 again, or yeah, 9:30, we will start it the session with the completer hands-on. So whoever is new here, the Spurs, you understand, right? Okay. Hmm. The heteroscedasticity. There are two things: homoscedasticity and the heteroscedasticity. So these all I'll cover this right now. You guys will not understand these two. Once we build it in the hands-on, I will show you that what these two are. You can easily find it out here in Google. Homoscedasticity. See that homoscedasticity. You can see, if I'll show you the images will look like this. So this is one of the assumptions. and we will see this. Okay, that why we use. Okay guys.